What caused the Earth's first mass extinction? First mass extinction on Earth. New modeling explores whether oxygen triggered the demise of 85% of marine species. Nearly 500 million years ago in the late Ordovician period, a mass extinction wiped out 85% of marine species. Scientists have now used modeling to narrow down the cause of this colossal loss of life, and they reckon it was due to a cooling climate. Throughout the last 500 million years, the planet has undergone 5 mass extinction events, where 75% or more of species disappeared. The fossil record tells us that the first, the Ordovician, occurred 440 million years ago. If you had gone snorkeling in an Ordovician sea, you would have seen some familiar groups like clams and snails and sponges, but also many other groups that are now very reduced in diversity or entirely extinct, like trilobites, brachiopods and crinoids, says co-author of the study Seth Finnegan from the University of California, Berkeley. But during the extinction event, species didn't disappear like the dinosaurs did when impacted by an asteroid. Rather, they went extinct over a period of up to 2 million years. So what caused this? Most research suggests that the extinction was associated with a cooling climate or changes in oxygenation of the ocean. Now, US-led researchers have looked at the ocean environment before, during and after the extinction event to find out what was brewing. In a study published in Nature Geoscience, the team took measurements of the iodine concentration of carbonate rocks from the Ordovician period, which served as an indicator for oxygen concentrations at various ocean depths. They then incorporated this geochemical data into numerical simulations and computer modeling to examine how oxygen levels changed in the ocean at the time. Turns out there's no evidence that oxygen decreased during that time in the shallow marine environment where most animals lived. This, the team says, rules out declining oxygenation as a single cause for the Ordovician mass extinction event. It instead suggests that climate cooling was likely primarily responsible. But interestingly, the research also shows that at the same time, oxygen increased in the deeper oceans. This can't be explained by the classic model of ocean oxygen, according to lead author Alexandre Paul from the Université Bourgogne-Franche-Comté in France. Upper ocean oxygenation in response to cooling was anticipated, because atmospheric oxygen preferentially dissolves in cold waters, Paul says. However, we were surprised to see expanded anoxia in the lower ocean, since anoxia in Earth's history is generally associated with volcanism-induced global warming. Paul and team suggest that the deep water anoxia was caused when global cooling altered ocean circulation patterns, stopping oxygen-rich water flowing from the shallows to the deep. For decades, the prevailing school of thoughts in our field is that global warming causes the oceans to lose oxygen and thus impact marine habitability, potentially destabilizing the entire ecosystem, explains co-author Zunli Liu, professor of Earth and Environmental Sciences at Syracuse University, in New York State. In recent years, mounting evidence point to several episodes in Earth's history when oxygen levels also dropped in cooling climates.